The Synthe MIPS is the most advanced cycling helmet GIRO has ever created. From its feathery lightweight and striking aerodynamic design to the latest developments in head protection, the Synthe MIPS is a step forward in cycling helmets. In order to understand how we can make a helmet that's as fast, light, and cool as the Synthe MIPS, let's take a look at the process required to create it. The first step is industrial design. We start with hand sketches to establish a design direction, then move to half-scale models carved from foam. Next, full-scale designs are sculpted in clay, then scanned into CAD for reproduction on our 3D printers. This full-scale model confirms the fit and is also used for aerodynamic testing in our in-house wind tunnel. When you see the Synthe, you see a single object. But it takes more than 100 parts to make this helmet, and every one of those parts has to integrate seamlessly. The low-friction liner, which is an essential component of the MIPS system, is just one example of how each part needs to be carefully designed, engineered, tested, and manufactured for optimal performance. The tooling required to make the Synthe is highly complex and can take up to 60 days to complete. We work directly with the factory to make sure that every piece of tooling, from the outer shell to the EPS liner and MIPS liner, is precisely machined for optimal fit and finish. A helmet as advanced as the Synthe deserves a beautiful finish. GIRO pioneered the process for applying silkscreen graphics to helmets, and we continue to advance the state-of-the-art. The graphics process starts with a flat design, either hand-sketched or rendered on the computer, and then plotted on a grid for scale. As the shell is formed from a flat sheet to a three-dimensional shape, the graphic stretches and distorts. So each design has to be adjusted in 2D to accommodate the distortion before it's handed off for manufacture. The Synthe's outer shell starts life as a flat sheet of polycarbonate. The process for applying graphics onto the polycarbonate shell is similar to applying graphics on a t-shirt or poster, where ink is pressed through a screen. Once the graphic has been applied, the polycarbonate sheet is ready for vacuum forming, which molds the flat sheet into a three-dimensional form. This is an intricate process where polycarbonate is softened with heat, then pressed onto a mold and formed with vacuum pressure. Once the shell has been formed, a CNC robot trims the shell and all of the vents in order to fit the helmet liner precisely. The heart of the Synthe is the foam liner, made of expanded polystyrene, or EPS. To create the liner, polystyrene pellets are pre-expanded in a chamber using pressure and gases that transform the tiny pellets into loose foam beads. Once expanded, these beads are injected into a mold containing the shell and other components that will become the helmet. A highly ventilated helmet like the Synthe requires a complex mold made of multiple pieces, which is assembled by hand, then loaded into the press where expanded EPS beads are injected into it. Heat, pressure, and steam inside the mold permanently bond the polycarbonate shell with the EPS foam beads. This process, called in-mold, reduces weight while enhancing durability and structural integrity. Once the mold process is complete, the operator disassembles the tooling to reveal the helmet. Next is the assembly of the MIPS system, which consists of 13 individual components that have to be connected by hand and then installed into the helmet. Once the MIPS system is in place, we install the fit system, the strapping, buckles, and aero mesh covers. The helmet is now complete and ready for inspection before being packaged and shipped. Every helmet we sell meets or exceeds industry standards for impact management, retention, and other factors that can help to reduce potential brain injuries. Our in-house test lab utilizes more than 50 fixtures that allow us to perform a full range of standardized tests, as well as exclusive fixtures that we have designed to evaluate rotational energy management. Once we've completed testing and certification, the helmet is ready for sale. This entire process, from industrial design through final certification, takes almost 3 years to complete, with thousands of hours invested by the whole team here at GIRO. But it's worth it to us. We're proud to have created a helmet as advanced as the Synthe MIPS, a product that can make a difference in people's lives.